So I already finished grading the test, which you guys are doing really good. So I want to say again, please circle your answer and also show your steps. If you didn't show your step, I will take it. I will, even though you get to the final answer correct, I will only give you partial credit, maybe 15% credit. If you show me the step, even though you didn't get to the final answer correct, I will still give you some partial credit, okay? Okay, so today I want to talk about chapter 7.1, which is reduce the rational expression. So the first step is, I'm going to tell you what is rational expression. Okay, first of all, rational expressions with something like x squared minus x plus 3 over 2x, or 3 over x minus 2, 4 over 9, such as a fraction. If some polynomial, you can write it into fraction form. We call this is called rational expression. They can have more than one variable, such as x plus y over 2s minus 3, or s plus y over s minus y, or y plus 2s squared over 5. These things are called rational expression. So usually you will have a top and the bottom. So on the top, I usually write it as numerator, a polynomial related to numerator. That's why I use the capitalized N, and then the bottom is denominator, right? But it's a polynomial that related to a denominator, so I use dx. Okay. So one thing that you need to be careful is the denominator, they can equals to 0. Okay. For example, if I have a rational expression x squared minus 1, 3x squared plus 5x. X can be any number. You can be 1, you can be -1, you can be 4, but there's one thing they can be is whenever the bottom equals to 0. So now let's solve it. Use the way that we learned in chapter 6, which is with fraction, we solve by factoring. So the common factor x, and then we have 3x plus 5 equals to 0. That means either x equals to 0 or 3x plus 5 equals to 0. So we subtract 5 on both sides over 3x equals to -5, x equals to -5 over 3. Okay, so that means what? These two numbers, x can be, because the bottom, you can't equals to 0. So x cannot equals to 0, or x cannot equals to -5 over 3. This is the domain. So that means we can use any value for x in the equation or the rational expression except for these two numbers, 0 and -5 over 3. Because once we use these two numbers, our denominator, which is 3x squared plus 5x, is going to equals to 0. When the bottom equals to 0, when the denominator equals to 0, the fraction would be what? Underdefined, right? Okay, now example 2. I want to teach you how to evaluate the rational expression. So for example, I have a rational expression x squared minus 4 and then x squared plus 6x plus 8 when x equals to negative 6. Okay, so that means what that is similar to the polynomial. That means we want to substitute x equals to negative 6 for each x in the expression. So we have what? Negative 6 squared minus 4 over negative 6, negative 6 squared plus 6 times negative 6 at 8. Okay, watch here. Why would I put a parentheses? Because if you don't put the parentheses, you will mess up with the sign. Look, if I don't have parentheses, that would look like negative 6 squared minus 4, and then negative 6 squared plus 6 times negative 6 at 8. Then these results, instead of a positive 36, you will end up to get a negative 36. That will totally lead to a wrong solution. So remember, when you try to substitute some negative number, always put a parenthesis just in case you will make a mistake. Because right now I'm teaching Math 111. A lot of students still making that mistake because they forgot to put a parenthesis. Always put a parenthesis when it comes to a negative sign. Okay. So now we follow the order of operation, which is the pandas. What is pandas? Parentheses, and then exponential, multiplication, division, and then addition, subtraction, right? We follow that order. So exponential first, negative 6 squared, we have 36 minus 4, 36 minus, you have a plus times a negative, then you have a minus, plus 8. So this is equals to 32 over 8. You simplify it, you will have 4. Okay, that's evaluate. That means basically it means you substitute whatever the design value into x for every x. And don't forget to put the parentheses. Okay, now let me give you another example. If I have x squared minus x plus 3 over 4x. This is a rational expression, and then I want you to evaluate when x equals to 1. What do you do? Similar idea, you just need to substitute every x with 1. Since this is a positive number, you don't really need to put a parenthesis, but I always put a parenthesis, just my habit, just in case, to prevent me to make some silly mistake. Okay, I have a 1 squared minus 1 plus 3 over 4 times 1 is 4. So I will have 3/4. That would be my answer. So the next one is, I want to say now how to reduce our rational expression. We have 15s to the 4th, y to the 2nd power 25 s second, y to the 6th. Okay, so how do we reduce that? So let's take a look. 15 and 25, what's the greatest common factor? Would be 5, right? So that for numbers, we can divide by 5 for both of these the denominator and numerator. So 15 divided by 5, I have 3. 25 divided by 5, I have a 5. So now I reduce to 3x to the 4th y squared, and then 5 times x squared y to the 6th. Okay, so I can expand this. So x to the 4th means what? You have 4x multiplied, right? Y squared means you have a 2y multiplied, and then x squared, y to the 6th power, 6y multiplied. Now we can reduce one by one. So since they have x, I reduce the common x squared, and then there's 2y, I reduce 2y. And now let's count how many remain. So for x, for the numerator, I have x squared reduced. And then for the bottom, which is the denominator, I have 5 times y. How many y left? 4y, which is y to the 4th power. If you're really familiar with that, you can just skip these steps, because you know that when you reduce, basically it's to subtract the exponents. So 4 subtract 2, you will have 2 remains, right? Let me use a blue one. So you have 2 remain, and 2 subtract 6, so you will have 4 remain in the bottom. So you will end up to have the same answer. Okay? Or you can consider this way. I have 15x to the 4th, and then y squared, and then 25x squared y to the 6th for the denominator, right? This is numerator and denominator. What I'm doing right now is basically I'm finding their greatest common factor and then try to reduce that part. So what's the greatest common factor, which is 3x squared y squared. So I have what's left of 5, I'm sorry. That's the common factor. What's left is 5x squared, and then 3x squared, sorry. 3x squared, and here I have 5y to the 4th, right? Basically, you're just finding the common denominator and divide them by the greatest common denominator. So what if this situation, if there is more than one terms in the denominator or the numerator, you can just factor them first or divide the common factor. Okay, so for example, I have 28 over 8x squared minus 16. So now we want to find the greatest common factor of the denominator first, since the denominator has 2 terms. So what's that? 8x squared subtract 16, so their greatest common factor would be 8, right? So I factor the 8 out. I have 28 over 8 times x squared minus 2. Okay, so now I can reduce. So now take a look, 28 and 8. What's the common factor for 28 and 8? Would be 4, right? So I can reduce by what? Dividing 28 and 8 by 4. Okay, if they all divide by 4, 28 divided by 4, you have 7. 8 divided by 4, you have 2. So when you reduce it, you should have 2 times x squared minus 2. Okay. I want to point out something, because I still see that a lot in Math 111, even though in a higher advanced math class, I've seen that a lot. So if you have a 28 over a squared minus 16. Okay, let's say this is an x, okay? You see an s in the denominator and an x in the numerator. You can't just say, oh, these two s, they can just reduce. No, you can't do that. If you want to reduce one x, every term needs to have x, which means you need to have an x for the 16. Otherwise, you can't just reduce the x for these two terms. Because in this rational expression, you totally have 3 terms, right? 1, 2, 3. You can just reduce the x in 2 terms. So the best way to do it is you find the greatest common factor for the denominator or the numerator first. For example, this one. I have 9x minus 3 over 18x minus 6. So now you need to find the common factor of the denominator and the numerator. So, okay, when you look at the numerator, the polynomial of the numerator, you have a 9x and this 3. So the common factor should be 3. So we have 3 times 3x minus 1 over the common factor of 18x and 6 would be 6. So I will have 3x minus 1. So look, the denominator and the numerator, they both have a common factor of what? 3x minus 1. So I can just divide out the common factor, which is 3x minus 1. So I have 3 over 6. And then I can keep reduce because they all both have a common factor 3. So I can divide by 3 on both. I have 1 and 2 left. So I have 1/2. Okay. Okay, so again, you need to be mindful. Remember, at the beginning of this course, I talked about that denominator, they can't equals to 0. That means what? 18x subtract 6, they can't equal to 0. So when I solve it, 18x can equals to 6. I divide 18 on both sides. So that means x cannot equal to 1/3. X can be anything, but they can divide by 1/3. Okay, another example. I have x squared minus 25 over x squared plus 8x plus 15. So look at the numerator. Is that familiar? You see x squared and 25. 25, we can write it as what? 5 squared. This is what? The differences of square, the special factor products. So when you look at the denominator, how can you factor it? Well, since our a is equals to 1, so that means we can use what? AC method to factor it. So now let's do it. So on the top, we have x plus 5 times x minus 5. For the bottom, use AC method. 2 number multiplied together equals to 15, and then 2 number add together equals to 8. Well, 3 times 5 equals to 15. 3 plus 5 equals to 8. So the two number we're looking for is positive 5 and positive 3. Okay, and then I can divide out the common factor, which is x plus 5, right? Top and bottom, they all both have x plus 5, so I can divide that out. So the reduced form should be x minus 5 and then x plus 3. Okay, again, what you can do. Oh, they both have an x. Let's continue to reduce cross the x. So the answer will be negative 5 over 3. This is totally wrong because x only appears in here, these two terms. If I have an x for the 5 and then another x times the 3, then you can reduce the x. Because we don't have, you can't do that. This is wrong. Your final answer should be what? X minus 5 and then x plus 3. Okay? So that's it for chapter 7.1, and we will continue about 7.2.